I need to make a correction for my previous video in which I tried to prove that the magnitude of the cross product between two vectors is just equal to the area of the parallelogram that they form. Now, technically, the proof I gave you wasn't wrong. It just wasn't the most general proof, because the proof that I used took into account that the two vectors were of equal length. Their magnitudes were of equal length. So it didn't work for vectors like this, in which the two vectors are clearly not of equal magnitudes. So what we're going to do today is we're going to prove that the area of this parallelogram is equal to the magnitude of the cross product two vectors. Okay? So instead of dealing with vectors, we're going to do the same thing as last time and simply deal with the magnitudes of the vectors. So let me get that sorted out here. Hope that makes sense. And it turns out that the area of a parallelogram is simply equal to the base times the height. I came to realize this, and so pretty much what we need to do is say that this cross product between A and B is equal to the area of a parallelogram, which is equal to the base times the height of the parallelogram. Now, it's actually really easy to do this. However, I want you to stick around until after we solve this formula that we're pretty much given that we can Google. Because if you want to be a better physics student, and I'm not saying you have to be the best. I'm not saying you have to be better than anyone else or the best in your class. I'm simply saying if you want to feel like you are doing everything you can to understand these concepts, if you want to feel confident and competent just within yourself, not compared to anyone else, then one thing that type of physicist does, the competent physicists question formulas like this. They question, where did that come from and why is that the case? Because if you're anything like me, like that's not explicitly obvious. To me, it's not obvious that the area of a parallelogram is just base times height. So we're going to prove that after we quickly solve this. Okay, so stick around for that. Okay, so the base, simple. It's just the magnitude of A. The height, pretty simple too. It's B, the magnitude of B times sine theta. That's the height right here. That's just trigonometry. Cool, okay. So yes, it is obvious that the magnitude of this cross product is equal to the magnitude of A times the magnitude of B sine theta, which is the area of the parallelogram. Okay, simple enough, right? But again, the important thing is, why is the area of the parallelogram equal to base times height? Guys, this channel, this is what I wanted to make this channel about, where we question the little details that can so often be overlooked. Because if we just let this go and we just memorize a formula, we don't completely understand what's going on with the problem. So let's solve it real quick. Let's figure out why it's the case that the area of a parallelogram is equal to the base times the height. And what we're going to do is divide this parallelogram into three separate areas, two triangles and one rectangle, okay? So with this diagram, we see that the area of the parallelogram is equal to area 1 plus area 2 plus area 3. Now, what we need to do is we need more variables. Of course, we're going to need the length of this base for the triangle, and I'm just going to call that G. I'm just going to call that G. We don't know what G is, but I'm just going to say that's G. And it turns out that this triangle also has the same base of G. That's just how the diagram, the geometry works. And we need one more length. We need this section here. And this is going to be the magnitude of A minus G, right? Because the magnitude of A is this entire thing. So this section has to be A minus G. Now we're all set up to solve for this. Now the area for triangle number 1 is simply going to be its base, which is G, times its height, which is B sine theta. Remember, B is a magnitude, but I'm not going to put it down as a magnitude right now. Divided by 2. Now the area for the rectangle 2 is its base times its height. So its base is going to be A minus G. Actually, I will do it as a magnitude, just to be consistent. That's the base times the height. Let me fix it real quick. A minus G times its height, which is, again, the magnitude of B sine theta. And for the last triangle, area 3, it's going to be its base, which is G, times its height, B sine theta again, divided by 2. Got it? I hope that makes sense. Now, terms 1 over here and term number 3 are exactly the same. So we just add them together, and their halves cancel out, So they're just wholes. It's just g times b sine theta plus, now what I'm going to do is distribute a here and g here. I'm just going to factor it out. So we get two more terms. It's a times the magnitude of b sine theta minus g times the magnitude of b sine theta. Okay? And as you can see, these two terms cancel out. So what we're left with is the area of the parallelogram is simply equal to the magnitude of a times the magnitude of b sine theta, which is the magnitude of the cross product, and it's also equal to the base times height that we found earlier. Okay? So that's the correction I wanted to make, and I hope it clears things up and that you now have a genuinely complete understanding of how to connect the magnitude of the cross product of two vectors to the area of the parallelogram. I hope that was useful. If you learned anything, or if you think my explanation could have been better, or if I've missed an easier way to do this, please let me know down below, because that's what we're all about here, just sharing our knowledge so that we as a whole can get better.